Hello, welcome back to Internet of Things class. And we'll be talking about telecommunication and global internet infrastructure. And we will expand it by looking at the fundamentals of telecommunication, look at internet backbone and data transmission, we also look at the sea internet cable and global connectivity. We look at satellite communication system, the spectrum allocation and regulation, and lastly the quality of service in Internet of Things network. And this will be brief, picking briefly. We have the notes where we have been able to explain more. The module actually focuses on the fundamental concepts, technologies, and global system that enables reliable communication and data exchange in the Internet of Things. And telecommunication provides the backbone for connecting devices, sensors, and systems across local, regional, and global networks. And understanding the principle of telecommunication is very important for designing and managing of Internet of Things system that depends on consistent, secure, and high performance connectivity. And this module explores the core components of global internet infrastructure, including the internet backbone, the submarine cables, and the satellite communication system, which collectively ensures worldwide connectivity. Coming to the fundamentals of telecommunication, when we talk about telecommunication, it's actually the science and technology of transmitting information over distance using electrical, optical, or wireless means. That's electrical, optical, or wireless means, and it forms the foundation of modern communication system by enabling devices, networks, and systems to be able to exchange data efficiently, reliably, and securely. And when we talk about telecommunication also, it involves the transmission, the reception, and processing of information between two or more points through physical media such as copper wires, fiber optic cables, or wireless channel. And the core objective is to be able to ensure that information is being delivered accurately, efficiently, and with minimal delay, which supports communication across local, national, or global network. And we have the characteristics here as it pertains to signal transmission, the bandwidth, and the data rates, the transmission media, which is copper, fiber, or wireless. Also, switching and it process switching and routing. And lastly is the reliability and quality of service. As per the internet backbone and data transmission, when we talk about internet backbone, what do we mean? It actually refers to the high capacity network of routers, fiber optic cable, and the interconnections that forms the core of global internet connectivity. And it provides the primary pathway for transmitting vast amount of data between regional networks, internet service provider, data centers, and also end users device. And this backbone that we are talking about operates at extremely high data rates, often measured in terabytes per seconds, and it uses packet switching technologies to be able to efficiently route data across redundant fault tolerant paths. And the standardized protocol such as the TCP or the IP ensures interoperability, while global interconnections enable seamless data flow across continents. And for Internet of Things, the internet backbone is essential for centralized data processing, global scalability, and time-sensitive applications. For the submarine sea internet cable, this is actually They are cables that are primarily physical. They are the primary physical infrastructures that enables global internet connectivity. And these fiber optic lines oceans are laid across oceans to be able to connect continents, countries, and major data hubs carrying the vast majority of internet traffic. And the submarine cables are engineered to withstand extreme underwater conditions and can transmit terabytes of data per second with low latency. And this provides high capacity, redundancy, and reliability, forming the backbone of the global internet infrastructure. And for Internet of Things, submarine cables enable low latency internal national data flow, and it supports global integration of distributed systems such as supply chain monitoring, asset tracking, and multinational smart grid management. Moving to satellites, the satellite communication system, it's actually um, it's actually used it's a communication system which is used for artificial satellite orbiting the Earth to transmit and receive signals over long distances, complementing terrestrial network. And they provide connectivities in regions where submarine cables or ground infrastructures are unavailable, such as in the remote rural areas, the oceans, and mountainous regions with mountains. And satellites operate in um, geostationary low Earth orbit or medium Earth orbit position, each offering distinct coverage, latency, and capacity characteristics. And while the geostationary satellites introduce higher latency, the LOE and the MEO satellites reduces delay, making them suitable for the real-time Internet of Things application. And satellite system supports mobility, wide range coverage, and reliability in extreme environments, enabling Internet of Things applications in maritime tracking, precision agriculture, disaster response, and remote monitoring. While comparing submarine cable and satellites. You see that the submarine cable and satellite communications forms a complementary global network that enables or ensures seamless Internet of Things operations across all environments. And since we've talked about it, I'll just brush it. Submarine cables, its primary high capacity backbone for global Internet of Things. It provides low latency, high bandwidth connection between densely populated urban centers and data hubs, and it's essential for data heavy real-time applications like financial system, autonomous vehicle coordination, and cloud analytics. And for satellite communication, it is universal coverage safety net for Internet of Things, and it ensures connectivity for devices in remote, rural, maritime, or highly mobile environments, and they are critical for applications where terrestrial or submarine infrastructure is absent or impractical. And together they create a resilient and truly global connective tissues for Internet of Things, ensuring no device is beyond reach. For the spectrum allocation and regulation, the electromagnetic spectrum is a finite natural resource that enables wireless communication, and the spectrum allocation and regulation involve the organized assignment and management of frequency band for specific communication services to ensure efficient interference free and equitable use. And the regulatory authorities such as the ITU globally and the FCC in the US oversees spectrum assignment and enforcement role. The spectrum is actually divided into the license band, which is reserved for specific operators, and the unlicensed band, which is available for general use by technologies like Wi-Fi and the Bluetooth. And effective spectrum management prevents signal interference, guarantee interoperability and scalability, and it ensures or enables uh, predictable performance and innovations for Internet of Things deployment. And lastly, we look at the quality of service in Internet of Things network. And what is the meaning of the quality of service? Quality of service. It actually refers to the performance guarantees provided by a network to ensure reliable, efficient, and timely data delivery. And in Internet of Things network, the quality of service is essential because devices often operate under constraints such as low power and limited bandwidth while supporting critical applications that demand real-time performance. And key quality of service parameters include latency, jitter, um, bandwidth, throughput, reliability, and packet loss. And the quality of service mechanism such as the traffic shaping, bandwidth, reservation, error detection, and adaptive management prioritize critical traffic and optimize resource usage. And for Internet of Things, the quality of service ensures timely and reliable data delivery for mission critical application, um, enables performance-sensitive automation, and differentiates service for diverse application needs. In conclusion, the module has been able to provide a comprehensive overview of the technology system and the regulatory framework that forms the foundation of global connectivity in the Internet of Things. And it covers telecommunication fundamentals, the internet backbone, the submarine cable, satellite system, spectrum allocation, and lastly, we were able to talk about the quality of service briefly. And we come to the end of the module. Thanks for listening.